and welcome back to nVent PYROTENAX World Headquarters. We're developing a short series of videos to help explain the most common codes regarding critical life safety equipment. Today, we're going to be talking about fire pumps. Fire pumps are regulated in the US by NEC Article 695 and in Canada by CEC 32, National Building Code of Canada Sections 3.2.5 and 3.2.7. These are all geared towards protecting the facility and enabling fire suppression efforts, and that means keeping power available to the pump. You want your sprinkler system to have water when there's a fire. This is a significant departure from normal thinking about equipment, and it's critical to understand this fact. Once you understand the intent, then these requirements make total sense. For example, you don't want to install the fire pump inside a building where it could easily be destroyed by the very fire you're trying to put out. Minimizing or even eliminating its exposure to fire is a principle that makes total sense. The same thing goes for the requirement that it has a reliable source of power. A little less obvious is the requirement that its wiring be independent of other wiring, but when you think about it, this also makes sense as well. Regarding fire pump disconnects, something that may seem counterintuitive at first glance is that the disconnect is locked in the closed position. I can understand making a disconnect lockable in the open position, great idea for maintenance, but lockable in the closed position? And the reason is, you don't want that fire pump disconnect left open inadvertently, only to figure out when the building is engulfed in flames that someone accidentally opened the disconnect. The same rationale behind this lock is why the code does not allow an automatic means of protecting the pump against overloads, and also prohibits ground fault protection on the circuit. What do these codes have to say about electrical feeders for fire pumps? First code says that the power supply must be rated for at least 125% of the maximum current required to power the pump. In addition, feeders must be protected from fire. Regarding feeders, fire pump supply conductors, where routed through a building, the conductor shall be protected from fire for 2 hours using one of the following methods. A, the cable or raceway is encased in a minimum of 50 millimeters, 2 inches of concrete, or B, the cable or raceway is a listed electrical circuit protective system. Informational note number 1, fire-resistant cables are tested to ANSI UL 2196-2017, ULC S139. Let's take a look at each method. Regarding the listed electrical circuit protective systems, what does this look like? The cable or raceway is a listed fire-resistant cable system with a minimum 2-hour rating. This standard currently does not test for the presence of toxic and flammable gases that may contribute to fire hazards and can be given off by some listed systems. Apart from the hose stream test, the standard does not specifically test for mechanical strength during and post-exposure to fire for all listed systems. Full mechanical strength may be needed should building debris fall and impact cables in a real-life fire situation. The second methodology is when the cable or raceway is encased in a minimum 50 millimeters, 2 inches of concrete. A few facts about this option. First, this is a very old standard that was developed decades ago when 1 hour protection was the prevailing standard. There is no equivalent test to this standard for concrete encasement. There are no listed concrete solutions. In December of 2018, the NFPA Research Foundation released a technical note titled Fire Resistance of Concrete for Electrical Conductors. The primary conclusion of this technical note was that 3.6 to 5 inches of concrete is required for 2 hours of protection depending upon concrete type. The paper further recommends to use 5 inches to make sure that you cover all variabilities in different types of concrete. So the reality is 2 inches of most concrete types provides less than 1 hour of protection. Codes evolve slowly, but we fully expect that 2 inches of concrete will not be allowed in future code revisions, and increasingly we see that 5 inches of concrete is being used at many firms to ensure good engineering practice and to cover potential liability issues. Why is nVent PYROTENAX System 1850 mineral insulated cable the solution of choice for fire pump electrical feeders? Here's a few of the top reasons. 1. 2-hour UL listed FHIT 1850, FHIT 7 1850 system listing. And you now know that this is vastly superior to 2 inches of concrete, which can offer no more than 1 hour protection. PYROTENAX also provides uncontested electrical performance at high temperatures. supplies all the power your pump needs, even at elevated fire temperatures. It's complete in organic construction, zero smoke, zero flame spread, zero fuel contribution to fire, superior mechanical strength versus other 2-hour listed polymeric cables, and a 30-year factory warranty. We hope you found this video interesting and informative. To learn more, visit us on the web at pyrotenax.com. And remember, when it really matters, PYROTENAX System 1850 will keep that fire pump going longer than anything else in the industry. Thank you.